Hey guys, welcome back. This video should be viewed, I believe, on Thursday is where we're at now. I'm recording this on Wednesday, obviously staying a day ahead. So here are your homework answers to questions 1 through 3. Notice in your homework answers we are breaking them down into horizontal and vertical components. Okay, so there's a horizontal component for everything, and there's a vertical component for everything, okay? So there's your homework answers. I will be doing a homework check early next week. I'm thinking about doing it as soon as Monday, which will be my first day back, okay? So just kind of keep that in your head that, everything we've been doing this week, the expectation and the standard's still the same, okay? I still expect you to be doing your work. I still expect you to be working through your homework problems. I expect you to be watching these videos. I might not physically be in class, but we're going to find out real quick come next week who's been doing it and who hasn't been doing it, okay? And the train's not really going to stop, guys. We're going to keep rolling on. There's not going to be much review time when I get back. We got a test next week at some point, probably in the second half of next week. I'm thinking like Wednesday or Thursday maybe. So just kind of keep that in the back of your head as well, that there will be a test next week. Your test is going to have graphing on it, so being able to graph your vectors. It's going to have solving vectors or solving displacement through the trig method, okay? Breaking those up into components, those x and y components. And then this last part here, which is projectile motion, will be the final thing covered on that test, okay? So basically 3 major topics, 3 things we've covered, and I think a lot of detail over the past couple weeks. A reminder that the quarter is over on Friday, so if you have any missing assignments or something, that's something that you're going to want to reach out to me about, any missing assignments that you might have. I think what I'm going to do with the quiz, because a lot of us haven't done that quiz because of tennis matches or whatever it may be, is I'm going to basically give a 7 out of 7 for those of us that completed the quiz, so 7 out of 7 points, so it should bump us a little bit in our grades before the quarter's over. And then if you weren't here, okay, I'm going to exclude you from that quiz, okay? So some of you are going to get some amnesty on that. That's kind of the best method I think I could come up with me obviously not being physically in the classroom to kind of hunt people down to take a quiz or anything like that. So I think that's the method we're going to go with. That way I'm not marking 15 quizzes missing because you guys were at soccer or tennis or whatever's going on during the school day, golf, stuff like that, okay? So that's kind of an update as far as everything is concerned. Test next week. I gave you the quiz rundown. I'm trying to think if there's anything else that I needed to kind of reach out about. Mr. Radloff came in and gave you guys a rundown on the engineering project, the slingshot project, okay? You guys will get to hit me with a water balloon, which is something I'm sure a lot of you want to do. Anyway, right? So that project, I think the due date's set for November 11th. It's in your Schoology calendar now, so keep that in the back of your head as well. I think you guys have a couple weeks to kind of work on that before we end up presenting on that. We want to knock it out before Thanksgiving and Christmas break. We don't want it hanging over your head before Thanksgiving and Christmas. So without further ado, I'll kind of get started here. Per usual, guys, watch the video. If you have questions, hop on Zoom, ask me the questions, and we can kind of go from there as far as fielding questions go. I know a couple of you guys yesterday hopped on Zoom and asked me some questions. It was great. Feel free to do the same today. Also, yes, I can see your YouTube comments. I turned most of them off, I think. If I did that correctly, I turned YouTube comments off, but I appreciate the glowing feedback, Noah Gruen. It's always good to have a number 1 fan, right? Okay, so there's your homework answers. Everything's got a horizontal and vertical component. I didn't work them out here. They're not worked out. If you want me to work one out, let me know, and you can just hop on Zoom and I'll work one out for you, okay? So feel free to do that. I know a lot of us have questions a lot of times in class, and I can kind of iron those out if you guys hop on Zoom, ask me questions. Remember, for these questions, we are using the motion equations that we used last test, okay? They're the same exact motion equations you used last test. So all of us should have those equations somewhere in their notes. I printed off an equation sheet for you at one point. I don't think they're currently on the whiteboard, but as soon as I get back on Monday, I'll put them on the whiteboard for you. So just kind of keep all that in mind. All right, so today's question, you are standing on the top of a 15-meter tall building and you want to throw a water balloon to hit a friend on the ground below. The friend is standing 6 meters away from the base of the building. With what horizontal velocity? Okay, so I'm going to go ahead and make it known right now. I am looking for horizontal velocity. Okay, with what horizontal velocity do I need to throw the ball to make an impact on your friend? So what horizontal velocity do you need to throw this water balloon at to get your friend soaking wet? So first thing we're going to do, break things up into the y direction and the x direction. Okay, same thing we did yesterday, same thing we're going to start with today. Okay, it's just like finding components, right? Finding stuff in the y direction and in the x direction, okay? So first of all, we know that the building is 15 meters tall. 15 meters tall, okay? That is obviously going to be my delta y. Okay, so 15 meters tall is going to be my delta y. Okay, and you want to throw a water balloon to hit a friend on the ground below. The friend is standing 6 meters away from the base of the building. Okay, so if I draw a picture of this, okay, if I draw a picture of this, there's my building. That is 15 meters. My friend is standing 6 meters away. Okay, he is standing 6 meters away from the base of that building. Okay, so that tells me that delta x equals 6 meters, okay? So now I know delta y, okay, and I know delta x. I got both of those from the question. All right, let's start filling in some other stuff we know, okay? My acceleration in the y direction is always negative 9.8 meters per second squared, okay? Always negative 9.8 meters per second squared. Most of us should have that memorized by now. We've used it plenty last unit. We're using it again here in this chapter, okay? So I hope that you have that negative 9.8 meters per second squared number memorized at this point, all right? So we know our acceleration is that. We also know that our v initial in the y direction, okay? Our v initial in the y direction is 0 meters per second, okay? We aren't throwing it down, okay? We want to know what we threw it out at. All right, so we're going to say our v initial in the y direction is 0, okay? Our delta t is our 1, and our VIF, or I'm sorry, our VF, VF in the y direction, we don't care about right now. Okay, so that's kind of everything we know in the y direction. Let's come over here to our x direction. Okay, acceleration in the x direction is going to be 0 meters per second squared, okay? We are assuming that we are rolling at a constant velocity, which means we are not accelerating and we are not decelerating, okay? We are moving at that constant velocity, okay? So there is no acceleration and there is no deceleration, so my acceleration is 0, okay? Delta t, I don't know yet, okay, but I can figure that out from my y direction over here, right? Okay, so what we're going to find out is we're going to solve for delta t in the y direction, and then we're going to take the delta t that we find and plug it into the x direction, okay? So delta t, I don't know yet, but I can find, all right? And then Vix, okay? The question said what horizontal velocity, okay, do you need to throw the ball with? I'm sorry, the ball. Do you need to throw the balloon with? Okay, so our Vix is our want, okay? So Vix is my want. And then my VIF, okay, I don't necessarily care about. Okay, so there's all of our terms worked out. Okay, so we are going to go ahead and get started on what we need to find. Okay, so we need to find delta t, so I can plug that in over here to eventually find VIX. All right, notice over here, guys, notice over here you have currently 3 unknowns, okay? 3 unknowns. We don't know delta t. We don't know VIX. We don't know that V initial in the X direction. And we don't know VIF, which is that V final in the X direction, okay? So we don't know any of those 3 terms. So I'm not really able to solve anything in the X direction here at this particular moment, okay? So that's why I'm going to start over here in my Y direction, okay? So in my Y direction, coming down to the next page. Okay, so in my Y direction, remember we have our motion equations, and let me write those out here for you for a second. Here are your motion equations. VF equals VI plus A delta T. Okay, there's motion equation number 1. Number 2 is delta X equals VI delta T plus 1/2 A delta T squared. Okay. Number 3 is VF squared equals VI squared plus 2A delta X. Okay, and then the last one is delta X equals 1/2 VF plus VI delta T. Okay, so there are our 4 motion equations, okay? You do not need to memorize those, obviously. Those are a little lengthy, but there they are for you, okay? So when we go to our equation here for our Y direction, we are looking for the one that doesn't have VFY in it, okay? So VFY is the one that's causing us concern in the Y direction. Okay, so the equation that I'm going to use is that second equation there. Okay, I'm going to use that second equation here. This delta X equals VI delta T plus 1/2 A delta T squared. Okay, that is the equation I am going to use. So let's come down here to the Y direction, plug and solve. So first I'm going to write out my whole equation. Delta Y equals VI times delta T plus 1/2 A delta T squared. Okay, so there's my equation. Let's go back up here. My delta Y is my 15 meters. My VIY is 0 times delta T plus 1/2. My A we know is negative 9.8. Times your delta T squared. Okay. We know that this term we can get rid of because 0 times anything is 0. Okay, so I'm going to come down here. 15 meters equals 1/2 times negative 9.8 is negative 4.9. Negative 4.9. Delta T squared, if I take 15 divided by my negative 4.9, I will get 3.06. Square root both sides. Okay, and I should get a delta T of about 1.75 seconds. Okay, 1.75 seconds. All right, I can take that delta T and plug it in right here in my X direction, okay? Because no matter what, it's going to hit the individual at the same time no matter what, okay? So I know that it's going to take 1.75 seconds for me to throw my balloon and then for it to make contact with my friend's forehead, Okay, so now we are going to move into my x direction. Okay, what formula do I need to solve in my x direction? Once again, I am using the formula without VF. This should say VF in the x direction. Okay, I'm using the formula without the velocity final in the x direction. Okay, so come back to my equations. I'm going to use, let me find a different color here. Is this good enough to see? Yeah. I'm going to use that same equation because I don't know the velocity final, right? Okay, so come down here, we go to x direction. X direction. Okay, we're going to use that same formula, delta x equals VI delta t plus 1/2 a delta t squared. Okay, so delta x equals VI delta t plus 1/2 a delta t squared. Let's go back up here. What do we know? Let's just go ahead and plug it on in. Okay, my delta x was 6 meters, so come down here. 6 equals VI. Okay, VI was my want. I wanted to know what velocity I threw it with, so I'm going to leave that here. My delta t was my 1.75 seconds. I got that from the last question. Plus 1/2. My A is 0. 0, okay? My A is 0, so then I can get rid of this whole term over here, right? Because 0 times anything is 0. Okay, now I have 6 equals VI times 1.75 seconds. I take 6 divided by 1.75, and I will get that to be 3.43 meters per second. So then my answer is 3.43 meters per second. Okay, and that is your VIX. Okay, so that is kind of the breakdown of the question. That is how you should go about solving a projectile motion question like that. I hope that answers any questions that you guys might have from yesterday's homework, or any questions you might have about projectile motion. All right, remember, you're going to be having a test next week. Your homework for tonight, okay, I might do that question tomorrow. Your homework for tonight, I'm going to write it in here since I didn't have it, is questions 4 through 6, okay, 4 through 6. And then we will say homework check. Homework check is going to be on Monday. Monday's date is the 26th. So Monday 10/26 will be when we do the homework check there. Okay, so if you guys don't have any questions, go ahead, get started on those homework questions 4 through 6. If you do have questions, obviously pause the video, hop on Zoom, we can talk through it, okay? Outside of that, guys, have a great day. That's all I got for you right now. Thank you. Ugh.